Okay, we have to start 4.3. We're solving quadratic equations by factoring. So this is sort of what a lot of you guys have been sort of waiting for and wanting to jump into, and we finally get to do it. So if you're solving a quadratic equation by factoring, that is actually, don't forget, the same thing as finding the zeros of the associated quadratic function. So you might have the directions say solve 3x squared minus 17x minus 6 is equal to 0. And so if you have an equation, it's already got that set equal to 0. And that 0 is going to be very important to us. But you also might have, the directions might say find the zeros of the function f of x is equal to 3x squared minus 17x minus 6. And so these are actually identical problems. Your first step, if you've been asked to find the zeros of the function, is to set the function equal to 0. And when you do that, you see we're exactly at where we were before when we were solving a quadratic equation that had already set equal to 0. All right, so these are the two things we're going to work on. We are solving this by factoring. So it's important that this 0 be here, okay? So that must be 0 on one side of the equal sign. Once you've verified that that's a 0, we're going to go ahead and start factoring. So, you know, this one's got a couple of choices, but the 3x is not a choice. Only 3x and x. Then I have a choice on how to make the 6, and if I put a 1 here and a 6 here, that gives me minus 18 plus 1 together gives me a minus 17x for the middle term. So I have successfully factored it because I have checked it. Okay? In my mind, I have checked that when I multiply those together, I get back to this equation. So I've checked it. It's still equal to 0. But now I've gone from having these three terms, 1, 2, 3 terms, to having these two factors that are multiplied together. Because I'm in factors, these are a product of two factors, right? This is a product of two factors. And what we can do is a very special thing called the zero product property. And it is referred to as the ZPP, okay? So we're going to use ZPP. Zero product property simply states, you've seen it before, if I have a product of factors set equal to 0, that can only be true if it's true that A is equal to B. Oh, whoops, let me back up, that was wrong. Oops, misspoke that. On my eraser. That is only true if A is equal to 0 or B is equal to 0, okay? Or it's also true if they're both equal to 0, would be the completely finish that property. It does say both could equal 0. So we're going to use this idea for the solving our equation. Okay, so I had this factored form of my quadratic. Now I'm going to apply the zero product property that says this whole thing could equal 0 if the first factor is equal to 0 or if the second factor is equal to 0. So what I've done is I've turned one equation into two equations. I like to use my t-chart, and I can just solve each one of these separately now. Okay, so this was ZPP. So now let's go ahead and solve this 3x negative 1, x is equal to minus 1/3, and over here x is equal to 6. Alright, so I have these two solutions to my quadratic equation. Okay, so now I want you to go ahead and try one of these yourselves. I have a function, it's quadratic, 5x minus 20x squared, and I want you to find the zeros. I'm going to pause it, so you should pause it and work it out and come back. Alright, so if you want to hear my solution, I can give it to you. If you've got it, just move on. But when I factor this, I remembered that I'm always doing a common factor first, okay? So this wasn't the whole trinomial into a product of two binomials. This was just a common factor. 5 and x are common to both, so take that out. But that still leaves me with a zero product property. You want to look for multiplication dividing up your factors. Now I could have put multiplication here too between the 5 and x, and of course 5 would never equal 0, so that just doesn't lead you to a solution. But you know, you're looking for this, where's the multiplication symbol? Between those, you separate them into your factors, and each factor gets set equal to 0. When you solve each one separately, you get your two solutions. X is 0 and x is 1 over 4. Okay, so let's try one more thing. Okay, so we get to do one last little thing, so it's going to be fairly short. We're just trying to write an equation in standard form that has the given roots. What does that mean? If I give you the roots, for example, maybe I'll give you x is equal to 3 and -7 are the given roots. Could you write the equation for which this would be the, the solution? So it's kind of a backwards thing, and the way you do this is you take each one of these separately, okay? So I would say x is equal to 3, and you also want to say x is equal to -7. When I'm giving you roots, remember, and this is what a lot of you were not thinking about when you did that challenge question yesterday, when I give you roots, I'm giving you values for x, okay? I'm giving you what x is equal to. So x is equal to 3 in this case, x is equal to -7. That said, I can rearrange these, and what you want to do is you want to subtract 3 from both sides over here, and you want to add 7 to both sides over here. And what that does is it sets you up to now you have these two equations that are both equal to 0. So if this is equal to 0, then the x plus 7 is equal to 0. Then I could multiply 0 times 0 and still get 0. So let me do that. I'm going to put this one is actually equal to 0. Take that times the other one that's already equal to 0 as well. So 0 times 0 will still be 0. So what I've done is I've made a quadratic equation now because I have these two factors. And I'll just go ahead and multiply them together to make it in standard form. X squared minus 3x plus 7x, and then the minus 21 is equal to 0. And that is my equation in standard form that has the given roots x equal 3 and x equal -1. So if you think about it, all I've done is the exact problem where I've worked it backwards. Maybe if you looked at this first, that looks like how the question usually looked, and your second step would have been to factor it. Your third step would have been the ZPP, right? And then finally the fourth step, you would have solved each individual. So going backwards is exactly what we did in the previous two problems. So I'll give you one more as a you try. Go ahead and try it. You're going to write an equation in standard form that has the given roots. It'll be quadratic with those two roots, x equal 5 and x equal 1/2. Go ahead and pause it and come back. Okay, there we go. I've gone through the problem. I said x is 5, x is 1/2. Make sure they are equal to 0 by subtracting the 5, subtract the 1/2. But what I did here, you might not have thought to do, but we're not a fan of fractions. So I decided that I would lose the fraction by multiplying both sides by 2. And when I multiply both sides by 2, I still get the 0 on the one side, so I'm allowed to do that, and it doesn't affect this method. And 2x minus 1 is also equal to 0, and then I can multiply those things together without fractions and come up with this nicer looking quadratic. So that would be my final answer. And we'll take the rest of this up in class. Should be straightforward.